Our universe is never still. Galaxies swirl, stars explode, and planets dance around their suns. Time in this grand cosmic ballet seems to flow forward relentlessly like a river rushing towards an unseen sea. We experience this every day, from the rising and setting of the sun to the aging process we all undergo. But what exactly is time? Is it truly an unstoppable force, or could it, under certain circumstances, flow backward? Here on Earth, time is a constant companion. We measure it with clocks and calendars, dividing it into seconds, minutes, hours, days, and years. This rhythm of time governs our lives, dictating our schedules and shaping our perception of the world. We remember the past, experience the present, and anticipate the future. However, our earthly experience of time is just one perspective. When we look out into the vastness of space, we encounter phenomena that challenge our everyday understanding of time's flow. Einstein's theory of relativity revolutionized our understanding of time. It tells us that time is not absolute, but is relative to the observer's frame of reference. This means that time can be affected by gravity. The stronger the gravitational pull, the slower time passes. Nowhere is this effect more extreme than near a black hole, an object of immense density and gravity. Here, time is distorted to an unimaginable degree. If we could observe a clock falling into a black hole, we would see it tick slower and slower, eventually appearing to stop altogether. While relativity governs the very large, stars, galaxies, and the universe itself, quantum physics explores the realm of the very small atoms, particles, and the fundamental building blocks of reality. In the quantum world, time takes on an even more perplexing character. It is here that the possibility of time reversal emerges, challenging our fundamental assumptions about the nature of time itself. One of the key concepts in understanding time in quantum physics is the arrow of time. This concept is not just a theoretical idea, but something we experience in our everyday lives. From the moment we wake up to the time we go to bed, we are constantly aware of the passage of time. We see it in the changing seasons, the aging of our bodies, and the ticking of the clock. But what exactly is this arrow of time, and why does it always point in one direction? This arrow points from the past to the future, indicating the direction in which time seems to flow. It's a one-way street that we all travel on, whether we like it or not. Imagine a river flowing downstream. You can't swim upstream without a lot of effort, and even then you're fighting against the natural current. This is similar to how we experience time. It's why we see coffee spill but never spontaneously reassemble, and why once something is broken, it stays broken. This irreversible nature of certain events is a hallmark of the arrow of time. When you spill your coffee, you can clean it up, but you can't make the coffee jump back into the cup. This irreversibility is a key feature of our everyday experience. Why eggs break but never unbreak. Once an egg is broken, it can't go back to its original state. This is another example of the arrow of time in action. The broken egg represents a move from a state of order to a state of disorder, a concept closely tied to entropy. This directionality of time is linked to a concept called entropy, which essentially describes the tendency of systems to move from order to disorder. Entropy is a measure of randomness or chaos within a system. The second law of thermodynamics states that in an isolated system, entropy will always increase over time. This is why we see things age, decay, and break down, which essentially describes the tendency of systems to move from order to disorder. Think of a messy desk. It takes effort to clean it up and organize it, but if left alone, it will naturally become cluttered again. This is entropy at work, and it's a fundamental aspect of the arrow of time. However, some fundamental laws of physics at the quantum level are time symmetrical. This means that these laws don't care whether time is moving forward or backward. In the quantum realm, particles can behave in ways that seem to defy our everyday experiences of time. This time, symmetry is a fascinating aspect of quantum mechanics that challenges our conventional understanding of time. This means they would work just as well if time ran backward. Imagine watching a film in reverse. The events unfold in the opposite direction. but the fundamental interactions remain the same. This is what time symmetry implies at the quantum level. It's a mind-bending concept that opens up new possibilities for understanding the nature of time. Recent experiments have explored the possibility of reversing the arrow of time on a microscopic scale. Scientists have been able to manipulate quantum particles in ways that make them evolve as if time were running backward. These experiments are not just theoretical. They have been conducted in real laboratories with real particles. Researchers have successfully manipulated the quantum states of particles, making them evolve in reverse, like a film played backward. This is a groundbreaking achievement that challenges our traditional understanding of time. By controlling the quantum states, scientists can essentially rewind the behavior of particles, offering a glimpse into a world where the arrow of time can be bent or even reversed, making them evolve in reverse like a film played backward. These experiments show that on a microscopic scale, the arrow of time is not as rigid as we once thought. While we can't reverse time in our macroscopic world, these findings open up new avenues for research and potential applications in quantum computing and other advanced technologies. While these experiments don't mean we can travel back to the past, they do offer fascinating insights into the nature of time itself. They show that the arrow of time is not an absolute, unchangeable feature of the universe, but something that can be manipulated under certain conditions. This has profound implications for our understanding of physics and the universe. They do open up fascinating possibilities. The ability to manipulate the arrow of time on a quantum level could lead to new technologies and a deeper understanding of the universe. It's an exciting time for science as we continue to explore the mysteries of time and its many dimensions. Time travel dreams and possibilities. The idea of time travel has long captured the human imagination. From ancient myths to modern science fiction, the concept of moving through time has fascinated us. We dream of visiting the past to witness historical events or traveling to the future to see what lies ahead. Could we one day build a machine that allows us to journey through time, witnessing historical events firsthand, or even altering the course of history? Imagine the possibilities. Experiencing the rise and fall of civilizations, meeting legendary figures, or even preventing disasters before they happen. While the possibility of macroscopic time travel remains firmly in the realm of science fiction, the strange rules of quantum physics do not entirely rule it out. Quantum mechanics, with its peculiar principles, opens up a world of theoretical possibilities that challenge our understanding of time and space. Concepts like wormholes, theoretical tunnels connecting different points in space-time, offer tantalizing possibilities. These cosmic shortcuts, if they exist, could potentially allow for instantaneous travel across vast distances and even different eras. However, the immense energies required to manipulate these cosmic shortcuts, if they even exist, make time travel a distant prospect. The technology and understanding needed to harness such power are far beyond our current capabilities. Yet the dream persists, driving scientists and dreamers alike to explore the boundaries of what is possible. The significance of time, a human perspective. Why are we so captivated by time? Perhaps it's because time is so deeply intertwined with the human experience. It marks the passage of our lives, from the moment we are born to the day we die. Our memories are rooted in the past, our hopes and dreams in the future. Understanding time, then, becomes about understanding ourselves, our place in the universe, and the nature of reality itself. Unraveling the mysteries of time. The study of time is a journey into the unknown. Every new discovery raises more questions than it answers, pushing the boundaries of our knowledge and challenging us to rethink our place in the cosmos. Scientists continue to explore the mysteries of time through experiments, observations, and theoretical models. The quest to understand time is a testament to human curiosity and our relentless pursuit of knowledge. Our journey through time. Time, the river that carries us all along, remains one of the most profound mysteries in the universe. It flows ceaselessly, indifferent to our desires and struggles, yet it shapes every moment of our existence. From the ticking of a clock to the movement of celestial bodies, time is the silent witness to all that transpires. While we may never fully unravel its secrets, our exploration of time is a journey worth taking. Scientists and philosophers alike have pondered its nature, seeking to understand how it governs the universe. Is time a linear path, or is it a vast interconnected web of moments? These questions drive our quest for knowledge. It is a journey that takes us to the very edge of human understanding, forcing us to confront the fundamental questions about our existence and the nature of reality itself. As we peer into the depths of time, we are reminded of our own fleeting presence in the grand tapestry of the cosmos. So the next time you gaze upon a starry night sky, remember that you are witnessing a grand cosmic dance, a dance that has been ongoing for billions of years. Each star, a beacon of light from the past, tells a story of time and space, of creation and destruction, a tapestry woven from the threads of space and time. The Milky Way, our galaxy, is but one chapter in this vast narrative, a narrative that continues to unfold with each passing second. And within that cosmic ballet, the mystery of time continues to unfold. It is a mystery that invites us to explore, to dream, and to wonder. For in understanding time, we may come closer to understanding ourselves and our place in the universe. I hope you have enjoyed our journey. If you want more insight on latest scientific developments, hit the like button and subscribe.